Okay, this is 6.6 Advanced Algebra Trig Compound Interest. We started off the day by watching this video for a warm-up, and I put the link right here on the left-hand side. So if you need to sort of click on that, I don't know if you can actually in this video. That's kind of weird. Anyways, this is a good video about how compound interest works. It's kind of oversimplified, but it does get the job done. Okay, we had 3 boxes today. The first box that we spoke about was this idea of the fact that we're going to be using 2 different formulas for calculating interest. So there's 2 major formulas here for calculating interest. Okay, one of them is when you have a payment period, such as we'll get into that payment periods later. So that's going to be our n later on. So it has a equals p times 1 plus r over n to the nt power. I'll tell you what all these things mean in just a second. And the other one is continuously compounded interest, where a is equal to pe to the exponent of RT. Notice that n is not in this one because we have a base that is continuous, or e is this 2.71 special number that we have studied in the past. So here's what all these things mean. Okay, a is the amount you end up with. Okay, so that's how much you get when it's all said and done. P is the principal, and that's the amount that you start with. So however much you've got right now to put in the bank. R is your rate, and it's always expressed as a decimal. Important to understand. Always expressed as a decimal. N is the number of times you compound the interest per every 1 year. So if it is daily, it's going to be 365 days, because that's how many there are in a year. And then T, of course, is time. And all these things work for both equations, but notice that N does not exist in the second equation because we have a special base of E. Okay, here are the types of compound interest that we're going to talk about. Annually is 1 time per year. Okay, that's like basic simple interest there. Semi-annually means twice per year. Quarterly means 4 times per year. Monthly is 12 times per year, and daily is 365 days per year. So what these are over here, these are the types of N in this part over here. So these things right there, those are the types of N. Those are the numbers you're going to use. Okay, here's 2 examples we're going to start with. We had a principal of $400. We had a rate of 2%, so 0.02, expressed as a decimal. We had compounded quarterly, so we used 4 for that, so that means quarterly right there. Okay, and then T was 5 years, and we had a guess. And our highest guess was $500 in the classroom. Our lowest guess was $408. Remember, we're starting with 400, so it has to be more than 400. And so we had a range here of 408 to 500, and then we calculated to see how we did. So we had A equals P times 1 plus R over N to the NT, because I have a 4 for my number of N. My number of compounds per year, quarterly. So what we did is we figured out as a class, we did this part first together on our calculators, got the answer, then raise it to the power of 20, and then finally multiply by 400. So again, do the inside part first, then raise it to the power of 20, then multiply by 400. You end up with $441.96, which of course is an acceptable range, sort of in the middle-ish of where we figured out it would be. And then the third box, we did the exact same problem, except we changed N to continuous. So that's the clue when you see continuous that you're going to be using formula number 2, which is right back here, the continuous formula. All right, whenever it says continuous in your problem set, you're going to use A equals PE to the RT. Okay, so we have X is the amount we're looking for, A. We still had $400. We had 2% at a 0.02. N was continuous, so we're going to use E. And of course, the T was 5 years. We plugged it into our calculator, and we got $442.07, just a little bit more than what we had before. And that was basically what we did today. All right, compound interest.